In this module, we will be looking at Arctic from various perspectives. This module is going to be a brief introduction to the Arctic climate, sea ice, wildlife, melting ice, resource extraction, indigenous communities, environmental impact, geopolitical tensions, northern sea route, scientific research, permafrost, unique ecosystems, traditional knowledge, and tourism. So in the first one, we are going to look at Arctic climate. The Arctic has extreme cold temperatures. They have long, harsh winters and short, cool summers. The Arctic temperatures are influenced by its high altitude and distance from equator, if we assume there are no external factors. The Arctic's climate is also influenced by sea ice and global warming. Why the Arctic temperature is rising? There is a recent report which tells that the multi-month average surface temperature anomalies for the Arctic from 1980 to 2020. So they have a 40 years recorded data on the temperature of Arctic region. So they have 4 quadrants. First one is January, February, March period. Then April, May, June, the second quadrant. July, August, and then September, October, November. They have not mentioned December here. So this is how they have actually bifurcated the 12 months into 4 sections. And if you look at very clearly, from the year 2005 onwards, we see all red lines. Red line means there is an increase in the temperature throughout this particular month from the average. Similarly, if you look at April to May, April, May and June, still from 2004 onwards, there is a higher temperature. And if you look at the temperature or the degree increase, it is either 1 or 2 degree increase. And in the month of January, February, March, the increase is close to 4 degrees. It's more than 3.5 degree. And July, August, the increase is pretty small. That is only 1 degree difference is there. But when we look at September, October and November, the temperature increase is close to 4 degree, that too in the year 2020. So this is the anomaly which we are seeing. This is what is called Arctic temperature rise. This data is provided by Copernicus Climate Change Services. And if we very clearly look at the entire Arctic region, which area of Arctic is warming, if you look very carefully, Eastern Arctic, that is the Eurasian, that is the Siberian region, is becoming more warmer either in the January, February, March period or April, May, June period or even July, August period or even in the September, October, November period. We see the dark red color. The dark red color is equivalent to around 5 to 7 degree increase in the temperature in these regions. So this Siberian region is becoming more hotter, whereas if you look at the other end, so this is the eastern side, and if you look at the other end, that is Greenland and the United States, those places, that is the western end of this Arctic region, is actually shown in the blue color. Blue color means the temperature is decreasing. So this is what is the major anomaly even within the Arctic region. So the eastern Arctic region, which is the Siberian area, are becoming very warm compared to the western Arctic region. So in the later part of the lectures, we will be looking at why this anomaly exists. And the warming differential between the poles and the tropics is called as the Arctic or polar amplification. So that means tropic is at a particular temperature, Arctic is at a much different temperature. So the difference between these two places is called as Arctic amplification. And this Arctic amplification arises due to 1. The Arctic region's reflectivity of sunlight, which we call as a albedo effect. So we will be studying about albedo in the later part of this lecture. The changing ocean currents due to the melting of ice is the second factor, and the influence of ocean currents on the weather, mainly surface air temperature and moisture. These are all the various reasons which is responsible for the higher temperature in the Arctic region. And here the ESA had given a very nice poster which talks about the Arctic amplification intensification. That means Previously, the Arctic was warming little bit, but now due to global warming, the temperature rise had become very high. So the thawing of permafrost releases more greenhouse gases. So greenhouse gases mainly carbon dioxide and methane, which are responsible for the increase in the temperature, and the carbon dioxide in the atmosphere warms the planet also. So planet includes Arctic region also. The polar vortex events influence the Arctic heat influx. That means this is also one of the reasons why there is Arctic amplification. And the increased surface temperature leads to sea ice melt and the albedo feedback. So this is the positive feedback system. In other words, the higher temperature leads to more melting of ice. More melting of ice leads to more water. More water means the sunlight can easily be absorbed by the water. So that increases the temperature of the ocean. So that in turn melts even more ice. So there is a positive or albedo effect happens because of the temperature rise. And the fluxes in the ocean atmosphere and the salinity affect the biological carbon pump. So we will study about ocean acidification in the later part. The less sea ice means more ocean heating. So this is what we have seen. So greater thermosteric contribution to sea level rise also happens, and ice on the land melts, increasing the fresh water. So this reduced Atlantic meridional overturning circulation. So this is the jet stream which are getting affected by the influx of more fresh waters, changing the albedo, leading to warming and thawing of the permafrost. So this is what is happening in the land. So the temperature increases in the ground. Permafrost is any area where the temperature remains sub-zero for 2 consecutive years. So when the surface temperature increases, that actually penetrates the soil to some extent, and that leads to melting of the ice which is present inside the land. So the permafrost thawing also happens because of the rise in the Arctic temperature. So more water vapor because of the evaporation and the clouds leads to more solar radiation absorption at the surface. So this is also a positive feedback. Ice is melting, which produces water. The water evaporates, that actually traps more sunlight. So this is a vicious cycle due to which the Arctic ices are melting at much faster rate. And the next one is the sea ice. This sea ice plays a vital role in regulating the global climate patterns, and if there are more ice, they will reflect the sunlight. So that means the low albedo, high albedo will be there. That means lot of sunlight will be reflected, and the temperature will remain cool in those areas if there are more ice. And the sea ice also helps to cool the earth. But recent years we have seen there is an extended decline of Arctic sea ice. When we look at the decline, here is a graph which clearly tells about the average monthly Arctic sea ice extent, that is in the month of March from 1979 to 2024. So if you look at here, around close to 16.25 millions of square kilometers are covered in ice in the year 1979. And if you look at recently, in the year 2024, recently in the month of March, if you look at here, the amount of ice is close to 14.75 or 14.8 millions of square kilometers. But the sea ice is declining in a particular year, it increases in the next year. So that is how it actually goes. If you see that this is a zigzag curve, and if you look at 2003, the sea ice was comparatively close to 15.6 millions of square kilometers, which went drastically to around less than 14.5 million square kilometers in 2005. So from 2003 to 2005, there is a drastic reduction of sea ice. But in the year 2008, again the sea ice quantity increased and it went up to 15.2 or 15.25 millions of square kilometers. So there is a gradual change that is happening from year to year. But if you look overall from year 1979 to 2024, there is a drastic reduction. So data is for the March month, and similarly if we look at the September month, that time also there is a declining in the sea ice at a rate of approximately 13.1% per decade. So what are all the ways by which the sea ice reduces? One, it may be the reduction in the thickness of the ice, or there is a seasonal variability. That means it reaches its minimum in September and its maximum in the March. So this is again influenced by the weather pattern and the ocean currents. There are also regional differences which are seen. That means eastern Siberia is warming faster than the western area that we have seen in the temperature anomaly. So what is the impact of this sea ice decline on the ecosystems? This basically disrupts the food webs, and it also changes the habitat availability for species, especially for polar bears which hunt on the ice. And for seals also this is a major problem. And the changes in the ocean circulation pattern also changes the jet streams. And if you look at the food web, the polar bear is at the top of the pyramid, and we have benthos are there at the bottom of this seabed, and we have zooplanktons which actually produce food which is being consumed by other partners in the food web. We have seabirds, we have seals, narwhal, we have carnivorous amphipods. So polar cod is there, ice fauna is there. So there are various fish and other mammals which exist in this food web, and this is being affected by the change of sea ice.